Trigonometry, lesson 6.4 to 6.6. Graphing trig functions introduced. I do this differently than most texts do it. I like the way I do it, so tough. This is how I'm doing it. How'd you originally learn to graph something? Most people say, well, I made a table and I connected the dots. So we're going to make a table. Again, unit circle, unit circle, unit circle, unit circle. This is really everything. So let's go figure it out. Start at 0, and then I'll just do pi over 4 and go up from there. Looks like I might have supposed to use pi over 6 and all that, but I don't really care. And then I'm actually going to jump to 3 pi over 2 and 2 pi. At 0, sine is 0. At pi over 4, it's root 2 over 2, which is about 0.7. How do I know that? I'm a math teacher. That's my job. At pi over 2, it's 1. 3 pi over 4, it's 0.7. Pi at 0. Here it's negative 1. Here it's 0. So I'll give you coordinate planes from here on out. Always with the 4 tick marks. 2 pi, half of that, pi, half of that, pi over 2. Now we actually need pi over 4, which I never will draw on again, and 3 pi over 4. And then we also need 1 and negative 1. I'm going to put a dotted line here at negative 1 and 1 because my curve is going to bounce around in there. And this is just a good habit to get into. Let's graph it. 0, 0.7. So it's got a little curve to it. I don't penalize, but some people do if you try and do a curve like that. So, get it right. Again, up here and here, not the most beautiful of graphs. Then negative 1 and 0. That is a sine curve. It represents an astonishing number of real-world applications. Swing. You're on a swing. You swing from one side to the other and back. You're basically doing a sine curve. Maximum distance to minimum distance to maximum distance to minimum. It works amazingly well for so many things. Daylight over the course of the year. Daylight from the morning to the evening. I mean, it's unbelievable how many things fit into a sinusoidal curve. So, be ready to rumble. What's the period? What's period again? How long? In this case, the x-axis, although we could plot time on the x-axis. Until it repeats. From the unit circle, we know that sine repeats every 2 pi. Cosine, something very similar. You're going to get bored with this, I apologize. 2 pi, half again is pi. Half again is pi over 2. 1 pi over 2, 2 pi over 2, 3 pi over 2. I'm teaching it that way for a very specific reason. Be prepared for that in your near future. It goes up to 1, down as low as negative 1. Cosine, we know, starts at 1, and then it does the exact same shape as sine. Matter of fact, it is the same graph as sine. It just starts at 0 instead of pi over 2. This is where the sine curve actually is the other way around. It's back here at negative pi over 2. If you shifted this over pi over 2, that would be a sine curve. You need to memorize these two graphs. Not kind of memorize them, I kind of have a grasp on them. They have to be locked down because we are going to take this and build rapidly. So put a number out front. This is the amplitude. This is how far it goes up and down from the center line. I'm going to write this in insanely big letters. And I repeat it in a moment. And I'm going to set it off. This is a math teacher trick, and I do it because you need to know that amplitude is always positive. The distance can't be negative. Okay. I think I have a highlighter on here. Let me see if I can find it. Pens, highlighter. It's just frustrating. It's not a hard fact to remember, and nobody ever does. Just remember, it's always positive. It's called the amplitude, and it's always positive. Now, what if it's negative? And I'm going to start doing this. Amplitude equals 1/2. If it's negative, you just flip the graph. And let me show you. I'm going to start always doing this too. Period is 2 pi. We'll show you how that changes. Okay, off we go. 2, 3, 4, 2 pi. Half of 2 pi is pi. Half of that is pi over 2. 1 pi over 2, 2 pi over 2, 3 pi over 2. Up and down. How far now? Well, that's what the amplitude is. How far up and down we went. You might say, wait a minute. Back here you didn't tell me what the amplitude was. I didn't have to. We're graphing y equals sine of theta. There's an invisible 1 right here. So that's why it went up 1 and down 1. And that's why amplitude's always positive. It goes up and down from the center line. Ugh, little frustration coming through there. Apologies. So at this point you might say, well, it's going to be the exact same graph, except for the negative. You just relabeled it. And at that point I'll say, yes, that's exactly what I did. I have no problem with that. We're going to be curve fitting this eventually, and we want to just be able to curve fit it. We have to understand how each piece works. Cosine should do this. Negative cosine is flipped, starts at the bottom. Take a fair amount of pride in my curves. That one's not one of my best. I won't lie. All right, put a number afterwards. That's your vertical shift. It moves the center line up or down. So, amplitude, 4. Some people like to put a negative there. I'm cool with that. Period, 2 pi. Haven't changed period yet. We will. Vertical shift, 3. So vertical shift, 1, 2, 3. Dotted line. 1, 2, 3, 4, 7. 1, 2, 3, 4. Negative 1. Dotted there. Dotted there. Need my 4 tick marks. 1, 2, 3, 4. 2 pi. Pi. Pi over 2. 3 pi over 2. Sine. Start here and go up. Whoops. Is negative. Go down. Don't hit this line here. Hit this line. That's a mistake I'll make very often, which I'm ashamed to say. So, last one, I would pause it, try it yourself. I'm going to do it. Amplitude equals 5. Oh, by the way, I like rewriting it. Period equals 2 pi. Vertical shift equals 1. One, 2, 3, 4, 5, 6. Oh boy, that's really terrible. 1, 2, 3, 4, 5, negative 4. 1, 2, 3, 4, 2 pi, pi over 2, 3 pi over 2. Cosine, start at the top, no negative, don't hit the middle line, don't hit the axes. Boy, I make that mistake a lot. That's a good graph. I'm proud of myself. Put a little smiley face off to the side. That's it for now. We have 2 more lessons on graphing to do. So get this down, and as always, happy mathing.